Alright, day 2 is about graphing these piecewise functions. Later in the notes you're going to see where I copied a whole page of instructions that if you want to, you can learn how to get your graphing calculator to graph the correct pieces. I found that to be more work than necessary, so I'm just going to show you the way to do it with normal tables. Like I said, if you want to play with it, you're more than welcome to. Alright, so continuous versus discontinuous, how can you tell? Continuous is when you can trace the entire picture without picking up your pencil. Discontinuous is when you do have to pick up your pencil. You do not need to know what kind of graph it is before you start graphing. Alright, the graphing works itself out. They'll just ask you about it afterwards. Alright, so for number 8, we have g of x, and it has 2 pieces. So the first thing I recommend is creating a table for both pieces. So we're going to create an xy table for each one of the pieces, and we're going to do it separately. I highly recommend that you only type one of them into your calculator at once. So the first thing we're going to do is we're going to go to y equals and type in negative x plus 2. Now if you hit graph, you would see that entire line, and when you go to the table, everything's there. But what we need to do now is just copy the portion of the table that we're going to need. And this says we need all values of x that are less than 2. Now I'm going to tell you, even though that equal sign is not there, whatever these numbers are here, you want them showing up in your table, whether or not it has an equal sign. Alright, so I want all x values less than 2. So I'm going to go find on my calculator, and I have a 2, 1 is smaller than 2, 0 is smaller than 2, negative 1 smaller than 2, and 3 or 4 points are really all that you need. And then I'm going to copy the points that go with it. So 2 gives me a 0, 1 gives me a 1, 0 is a 2, and negative 3 is a 3. Now, I'm also going to do something else, and this is meant for a reminder, although a lot of kids still ignore it, but it's the best thing I've come up with so far. Since this condition up here does not have an equal sign on it, that means that when I graph the point when x is 2, I need an open circle because there's no equal sign. So to remind myself of that, because there's so much I have to do on this problem, I come to my table and I draw an open circle around my 2, and that is supposed to be a reminder to draw it as an open circle on the graph. Right? Problem is, just don't learn to ignore it. Alright, so now I'm going to go back to y equals, and I'm going to type in x minus 2, and go get a table. Now this condition says I want values of 2 greater than or equal to 2. Again, whatever numbers are here are in your table. So greater than or equal to 2 means 2 and up. So 2, 3, 4, and 5 ought to do it. And for 2, I get 0, and then 1, 2, and 3. So there are my table of values. Now, when it has an equal sign, I don't do anything special in my table because I'm just going to plot the points like normal. Alright, so I'm going to plot the points for negative x plus 2 first. So I have a negative 1, 3, a 0, 2, a 1, 1, and an open circle onto 0. I do need to connect these dots, but I am not going to put arrows on both ends. It's only going to go in one direction forever. And to figure out what direction that is, go back to your inequality that has your condition on it. And right here, I see a less than. Less than points to the left, which means I'm going to put my arrow on the left side of what I just drew. Okay. Now, if we go plot the next set of points, I've got 2, 0. Well, that's supposed to be a closed circle for 2, 0. So that pretty much just fills in the open one, and that's what makes this graph continuous, is I just filled in the plug, basically. 3, 1, 4, 2, and 5, 3. And I connect those dots. But I go back to the condition, and I see that x has to be greater than or equal to 2. That greater than sign is pointing to the right. That means I put my arrow on the right to show that my x's are getting bigger. Now to label this graph, you just take the name from out front. This entire graph is called g of x. You do not have to label the individual pieces. All right, well, let's do that again. So first thing we're going to do is make a table for each piece. Negative 3x plus 2 over here, and 1/2 x minus 4. It's kind of important that you write those down separately because anybody grading your paper needs to know which one of those equations you're writing a table for. That helps us with partial credit and stuff on our Regents. So I'm going to go into y equals, and I'm going to type in negative 3x plus 2 and go get a table. Alright, now looking at my conditions, they're pretty much the same as last time, aren't they? Close. X has to be less than or equal to 2, so I want 2 and down. Alright, so I need to copy stuff from 2 down. That'd be 2, 1, 0, negative 1. Like I said, 3 or 4 points is enough. We get negative 4, negative 1, 2, and 5. Now go back and look at the condition, and this time the 2 has an equal sign, so I'm not going to touch it in my table. Alright, that table's done. Now we're going to go into y equals and type in 1/2 x minus 4 and go get a table. And this says for all values greater than 2. But even though there's no equal sign, remember, I still want the 2 in my table. So 2 and up. 2, 3, 4, 5 will do it. 2 is a negative 3. 3 is a negative 2.5. 4 is negative 2, and 5 is negative 1.5. Alright. I'm going to graph the first, oh, wait a minute, and no equal sign here means I'm going to put an open circle around my 2 so that I don't forget to graph it that way. I almost forgot to do my circle. Alright, we're going to graph negative 3x plus 2 first. So you have the point negative 1, 5, 0, 2, 1, negative 1, 2, negative 4. Okay, I do need to connect the dots, preferably with a ruler, but I'm on my iPad, not going to happen. And to see which side to put the arrow on, go back up to your inequality. It's a less than pointing left, so we put the arrow on the left side. Alright, now I'm going to graph this one. 2, negative 3 gets an open circle. That's what that's there to remind me of, so I have an open circle. 3, negative 2.5 is about there. 4, negative 2. 5, negative 1.5. So I need to connect those. Be careful when you connect open circles. Don't go all the way into the center of your circle because then it kind of looks like you filled it in and people might think you did and they might mark you off for that. So make sure when you connect open circles you just connect to the outside. Alright, go back to your inequality. It's greater than, which points to the right, so our arrow is going to point to the right. And my function was called h of x, so to label my graph, I get h of x. Alright, I think we just have one more to try. Nope, we have 2. Alright, the next one has 3 pieces to it. So we're going to do x squared plus 1. Or we're going to do x plus 4. And we're going to do 5. Alright, so if we go and get a table for x squared plus 1. And it says we want values of x less than or equal to negative 1. So I want negative 1 and lower. Alright, so I'm going to do negative 1. We get 2, a 5, a 10, and a 17. Now I'm obviously not going to fit the 17 on the graph. No big deal, we still have 3 other points. Alright, so then we go and get x plus 4 between negative 1 and 2. So negative 1, 0, 1, and 2. Remember, even though they don't have equal signs, I need those numbers in my table. But that also means I'm going to put open circles around them because they don't have equal signs. Alright, so then we're going to get 3, 4, 5, and 6. And then for the last one, I don't even need to put that in my calculator. Y equals 5. The y values are always going to equal 5 for any x greater than or equal to 2. So that's 2 and up. 2, 3, 4, and 5. All right, let's go graph these. Blues first. All right, so x squared plus 1 is what I'm doing first. That's a parabola. I know it's a parabola because it's got a square in it. But remember, I'm only graphing the piece that they're asking me for. Negative 417 is not going to fit. Negative 310 will. Negative 2, 5. And negative 1, 2. Now remember, this is a parabola. Parabolas are curvy. So see, it's kind of a good thing that you know what kind of graph you're going to get before you start drawing it, right? The squared makes it a parabola. Okay. The inequality is pointing to the left because it's less than, so I put my arrow on the left-hand side, just like that. Now we're going to graph the red points. Negative 1, 3 gets an open circle. 0, 4. Whoops. Hang on a sec. I went over too far. Negative 1, 3 is right here. 0, 4. 1, 5. 2, 6, and I connect the dots. Now, because this is a sandwich, it told me where to start and where to stop. I don't put any arrows on this section at all. It starts and stops. So I'm going to go to the green one. And it says for x values greater than 2, we get a 5. So 2, 1, 2, 3, 4, 5. 3 gets a 5, 4 gets 5, 5 gets 5. Connect the dots. And this inequality is greater than, it points to the right, so I put my arrow to the right. Now, for those of you who are really liking this color scheme so that you can more easily see the pieces, you are allowed to use colored pencils on the Regents exam, which means they're erasable when you graph. So color is a good thing. I kind of like it. Label your graph, f of x, and this problem is done. All right, and the last one. So again, make a table for each one. Yeah, probably should do that a different color. Alright, so it says for x values less than or equal to, or sorry, no equal to, less than 3. So here's my 3 with an open circle, and then numbers under 3. So it's going to give us a 5, a 0, a negative 3, and a negative 4. Again, because of the square, I know that's a parabola, so I got to remember to draw it curvy when I do that. And we'll go get this one. And this says for values greater than or equal to 3. So I'm going to type that in my calculator. 2/3 x minus 5. Now when I go look at a table for this one, I'm getting some really nasty looking decimals. We really don't like graphing nasty decimals. 0.5s are fine. So instead of going 3, 4, 5, 6, because those are the numbers bigger than 3, I'm just going to write down numbers bigger than 3 that have a nice point to plot. So 6 has a negative 1. That's a nice number. Probably should get another one. 9 has a nice number of 1. So I'm not going to bother with the decimals. I'm just going to graph the nice ones. Alright, so the blue one first. 0, negative 4. 1, negative 3. 2, 0. And 3, 5. Whoop, and 3, 5 gets a open circle. See what I mean about forgetting it? 1, 2, 3, 4. Open circle. We said it was a parabola because it had a square. And we kind of see the curve anyway, so make sure it's a little bit curvy. Alright, the red one. 3, negative 3 had the equal sign, so it's a solid dot. 6, negative 1. And 9, positive 1. Connect the dots. Alright, on the red graph, we have a greater than. That points to the right. And I forgot my arrow on the blue one, so let's go back. The less than sign's pointing to the left, so I put my arrow to the left. Label my graph h of x, and this problem's done. Alright, so here's the instructions that if you really want to teach yourself on how to do the pieces on the graph, the calculator will actually do it for you. I thought it was too much trouble to bother with, but for those of you who want to play around, go for it. And then you have some homework problems where you get to try to graph these.